Hello YouTube! So earlier today I made this cool little parkour course and I was wondering how long it actually took to get through all the certain sections in case me and my friends want to do like races and give out prizes and stuff for best times in certain sections and best overall time. And based on wanting to know that, I went ahead and made up a little computer craft program that will monitor the times for all the sprints. So let's go through here real quick and then see how it works. And then we'll get into how I made it in the rest of this video. So first we'll just get through all these little parts. I'm gonna crash and bang. I'm gonna cheat a little bit, use my jetpack. We'll just get through this section. Yep, you get the point. Jetpack here too. All right, you can see the sensor there. And now we're on the last section, cool little jump. And now we'll go back and you can see my times on the 4 different little sections and my overall time. And I'll show you how we coded this up, and you can also get this code in the link in the description, so check around for that. Now let's see how this thing is made. RF tools in it, which has a block called the sensor, and you can set the sensor up to count the amount of players. So when you go through this, you know, you can see that thing right up there turning red right in front. And you can use that pulse to kind of like determine when someone goes by this and then when they go by another one. And then you can do some math to get like the actual segments. What do they call those in actual racing? I forgot what they call them. The splits. Yeah, so you can get the split times and all that other fun stuff. And if we have the ability to censor when someone goes by something, then you know we can have the ability to write a program to monitor those sensors. And this mod pack also has something called Computer Craft in it, which has a advanced computer and a monitor. So I can go in here and I can use this just like a normal computer. You know, I can do ls, I can edit files, I can edit a folder. I think I can make a directory called like scripts. And then now you can see that folder's in there, and then I can cd into scripts, and then I can also call a Lua command prompt. And I can do stuff in here like print hello, so you can see hello. And then we can also monitor the redstone that is being input from our sensor, and we can print that onto this big monitor to the right here by using this as a peripheral. Let me actually, we'll show you this. So monitor equals peripheral, it's a hard word to say, right. So the monitor is to the right of the computer, and then we can do monitor dot right foo. Oh, and apparently when I did monitor dot right, it showed everything else that was on the monitor. So we can do monitor dot clear, so that'll reset that, and then we can do monitor dot set the cursor position. And we set this to 1, 1. Normally computer science, you start with 0, 0, but not in this one. And then we can do our foobar. And now you can see foobar showed up on the monitor. We can write a computer program that will display the sprint times, display the best time. I don't think we can actually get the player name with this. If we could, and we could send the player name to it, then that would be great. And then we can actually monitor the high score like even more automated, but we can't do that. And we can get the split times. We can record them down here by seeing when a redstone pulse is sent to it. We can use some wireless sensors on each of the segments to make 4 different pulses going into here. So this will actually be pretty cool. And then we can use the strength of the signal to determine which split timer is sending us info about the time, and then we can record that, and then we can get the overall score once they get to the end. And I'll actually show you the end element right now because that's kind of cool. It's kind of like a high dive. So, oh no. So this is the 3rd obstacle here. I call this the climbing tower, and then after the climbing tower you jump onto the slime blocks, and then you get here, and then we'll have our last sensor, and this will be the end time for the total time and all that other fun stuff. And now that I've explained that all to you, you know, we just need to write the program. So let's go in here. Let's clear our monitor. I wish there was a way to just turn the monitor off. We can use the ComputerCraft API documents to interact with the different elements. So here is the terminal API. That's where I was getting the set cursor position thing from. And I can get the size to make sure we're not going out of bounds for our text. And what I'm looking for is there a way to actually turn this off? Which it doesn't look like there is. Clears the line the cursor is on. So clear line, that actually seems like a nice command. Anyways, for our program, what we're going to want to do is we're going to want to create a loop that just checks for the different pulses from the different sensors that we're going to create. And then if it gets a pulse from the very first one and we're not already monitoring time, so we're going to create some flags in here. When it gets that pulse, it will start a timer. It will display the timer on this monitor. And to do that, we're going to need to clear it and constantly refresh every time it updates. So it gets the illusion of showing an actual time. So let me just figure out how that works, and then I'll come back and describe the code that will just make a counter on the monitor. With this project, we're going to want to break things down into small pieces of functional code, or functions, in other words, and then we're just going to call the functions kind of one by one through our loop to check the different elements and update our program. All right, guys, we are back, and we have a little small Lua program here that sets a variable of counter equal to 0, counter max equal to 20, and then we get our terminal instance by doing the peripheral.wrap to the right of our computer. So let me so you can see, here's our computer, and then to the right of it is the monitor. And then, that allows us to interact with the monitor via some of the terminal APIs that we talked about. And then we just do a little simple loop while counter is less than the counter max. We clear the terminal line, so that way if we have text written in other places, we get to keep that. That'll be relevant in our final program. And then we set the cursor position so that we can write a new thing. We write the updated counter, we increment the counter by 1, and then we sleep for 1 second. What this will let us do is pretend that the program is actually counting and that the screen is updating and showing that counting. So now I can go ahead and run this by hitting Control and then saving, just because we always want to make sure we save stuff, and then go ahead and running. So now in the top corner, you can see our monitor is counting from 3, 4, 5, and then it'll go all the way up to 19, and then it will stop because 20 is not less than 20, 20 is equal to 20. This shows us how we'll be able to display the times of the different sprints on our course by printing out to the terminal and using the sleep timer to increment whenever we're looking for events that have happened that get input from our various redstone elements. This will be the first building block that we'll use. So this will kind of be like terminal interaction. And then the next thing we're going to need to do is actually detect when something passes the sensor to kind of start our main program. So we're going to have some states that will monitor at what sprint a person is in, and then we'll get those sprint times, we'll save those, and we'll print them to different lines. Should end up being pretty cool. So we'll see how this evolves as we figure out the new pieces of our system that we want to program and output to the monitor. So we'll be back after we figure out how to get the input from the sensor and have that start up a flag for us. All right, we did some coding and we're back. Made some progress on the program. We added in this little while waiting for runner do if redstone.getAnalogInput on the left side is greater than 0. Then we set our waiting for runner flag to false. We clear the terminal line. We write runner found. And then we write after how long after the program started we found a runner. And if there is no analog input, we simply increment the counter by 0.01 and we sleep for 1/100th of a second. So what we've added now is every 100th of a second, we'll check if there's a redstone pulse, and if there is, we'll do something. So I'll go ahead and show you this. We'll go ahead and exit. We'll run the park challenge. So we can see we initialized our monitor and it says it's waiting for runner. We'll get ready here. and we'll go. All right, so we do a couple steps and we're gonna end this and then come back. And then we can see our monitor has updated to found a runner after 2.18 seconds. So that's really cool. But the problem with this implementation is every 1/100th of a second, we are checking for redstone input right here from our sensor. There's also a way to do a os.event or os.wait. So we can like have our program wait for the input to actually come in. And I think doing that will actually simplify our program. So instead of checking the flag ourselves, we'll use an event handler. And I think that should simplify things. So I'm gonna go ahead and play around with that and refactor the code a little bit. I'll come back once we have the event handler in here instead of checking every 1/100th of a second. And then after that, we just need to add event handlers for each of our sprints, print out the 4 different sprints, and then add them all together for the total time of the parkour course. And I think, you know, that'll be a pretty cool application, and maybe we can make that in a modular way, and maybe we'll add on a button as a follow-up video. But for now, we're making pretty good progress, and let's see what happens. All right, guys, we're back. We've made some progress. We did that refactoring we talked about, so I'll go ahead and show you the new program now. We added in some comments, but you can see we're using this OS pull event redstone now, and if the input's from the left, well, it doesn't really matter if the input's from the left. The left is going to be the only side that can give us redstone right now anyways, so we don't really need to do that check, but we can get the analog input and do stuff on those values to let us know what channels are actually sending us different signals based on their position. And then we go ahead and we write runner found. And instead of keeping a manual counter, we're able to start a timer using OS clock, which monitors the time from when the computer was turned on in seconds. So everything in OS clock is going to give us seconds. So the time start, you know, OS clock, and then after we get our input signal, if we do a new OS clock minus time start, then, you know, we'll get the difference between those two things in seconds. So we write the output of how long the time was since we ran the program. So I'll go ahead and show you. I also set up the other sensors. So, you know, this is kind of hardware to our software. So these sensors will tell us when different things happen, such as in this case, it'll be when the runner reaches a certain position. So we'll save whatever we've done, we'll exit. We run the program by just typing in the program name. So you can see our monitor has changed, parkour challenge, waiting for runner. And instead of doing the same demo I've been doing the whole time, we're just gonna fly over here to the second sprint number. That second sprint number is gonna correspond to this sensor. And when an event happens, we take the input signal and we're going to subtract that from 15 to get what sensor actually kicked off the event. So we're using the signal strength of the redstone here to determine what actually triggered something. So if we go down here and we just land, oh gosh, can't even land. This jetpack's very fast. All right, so we're landing, we're doing our things. But if we go back to our program, we should see that something happened. So we can see runner found. It took me 40 seconds to land in front of that thing after I explained to you guys the sensors. And if we go in here, we can see that 13 was the signal strength that triggered our event, which would correspond to this one. And then, so 15, 14, 13 would be the strength when it came here. So that's how we're gonna use this different signal strength to check which sensor is actually giving us an event. We could just assume that people are going to be perfect and that they're going to be able to hit this every time. But if they fall, you know, they come back on this ladder and then they're going to come over here and then this is going to be another redstone event. So we actually need to track the position, and that's what we're doing in our software. All right, so now that we know how we're going to actually get different signal positions, I'm going to go ahead and write some more code that will calculate the sprint times using those positions, and hopefully it'll make more sense. And then after we have that code written in a modular extendable way, we'll be able to run through this and actually get a calculated time. So I'll be back in a bit. All right, everyone, so we've been coding for like an hour-ish, I want to say. I don't know, you can probably see the time in the bottom right corner if you really care to look that detailed. But we got the finished code. We got it here on Pastebin. I'll put the link in the description for y'all if you want to download it and play with it yourself. But anyways, we have a initialized current split. The number of splits that we have, this number is dynamic, so you can add extra amount of splits if you have the sensors and the redstone receivers and transmitters and all that stuff. The rest of the code will just work, so it's extensible in that sense. You just need to come in and change this to the number of splits you end up putting in your course if you end up making your own parkour course. You also are limited on the size of the monitor you pick. So if you have the 2x2 monitor like I do and you don't have enough lines for how many splits you do, it might end up running off on the bottom. I think it should be able to support up to like 8-ish. The total time might get cut out. But anyways, we got some other initialized variables. We got a function that handles printing output by incrementing our position dynamically based on the split we're on. And then we have a awesome monitor initialization code. We got some while true do. This is where we look for all of the redstone events we get. We have a flag here. If our current split is equal to the split event minus 1, that means we're at a new split, in which case we should initialize it. And if it's the first time we're doing it, there's some special logic we do to initialize the monitor. Because if we start it back over again, we need to clear out the monitor completely and then print out the new split details. If it's not the first time, then we're just going to display the split times with these 3 monitor writes and this tracking logic here. And then if the split event equals the final split, that's where that num splits comes from, and the dynamicness of the whole program that makes it so you can add 6 or 8 or however many sections, up to 15 based on the redstone parsing, but then you need a really big monitor. And it should work for up to 15. We might try that later on. Like and subscribe to this if you want to see me. We might do that later on, so definitely like this video, subscribe, leave a comment if you want to see me do a 15 split section and show that it's still dynamic for that amount of sensors. But anyways, if we're on the last split, we write our final time, we do a final time calculation, and then we reset the line where it says good luck runner to waiting for runner to let the user know that the application is in a new state where it can be used to do a new event. And then, that's pretty much it. We end it, and then we download it onto our program in the game. Let's just go ahead and fly over there. All right, we're back in the game. We're gonna download that program and initialize it. This was the old results, but we'll go ahead and we'll go into the Lua console and we'll do a, man, I don't wanna do all that. Anyways, I'll just show you what the directory looks like right now. We'll get out of this Lua console. So you can see there's a part 2. So we're gonna remove part 2 and we're gonna get the Pastebin script that you guys saw that I was just showing you. So this idea is the same. You can run the same command in your world and play with the script there. So we're downloading it as part 2, and we'll go ahead and run it as part 2. And you can see our monitor has erased. And we'll go ahead and start this thing. I'm not going to run through the whole thing because the third part is actually kind of tricky, and I don't want to choke it on camera. But we go through this. Maybe I can get up to the second. And I fell. All right, we'll use our flight to get up here and cheat. So, okay, we're here. But now you can see we go back over. We have our first split time was 7.15 seconds. Second split time, 7.15 seconds. And we'll just keep using our flight to skip this part. This is our third sensor here. So now we're here. Then we're gonna do the slime jump. So basically you just got to run as fast as you can and then jump. And this should be the fourth one. And that's all of our splits that we have for this parkour challenge. And you can see the third one was pretty long because we were talking about it all. I believe this is in seconds, but 17, you know, that sounds pretty short from how long we came over here and we're talking and then flew back. But regardless of what the measurements are in, you know, we're getting all the times correctly. We're getting the total time, and you can see that the text up top, again, is said waiting for runner. So we should be in a new application state where we're looking for the initial flag. So if we run over here and start it again, you can see that the application is reset and we're in a good luck runner state. So if we go over here to 1, you know, all right, we're on the sensor. You can see that 1 has been added and it took us 10 seconds to fly over there. All right, so that's the program. Hope you guys have learned something about, you know, what we try to accomplish in programming and reading in sensor data and monitoring to events and, you know, just some cool stuff to do in Minecraft. If you want to see more Minecraft, I'll link to my gaming channel. I have some Minecraft videos in there, and I have a couple on deck to upload. I haven't been uploading them because I haven't been getting views, but if you want to see them, definitely let me know in the comments, and I'll go ahead and start sharing more stuff like this, and I can make more random computer craft stuff that has actual in-game applications. All right, thanks for watching. See you guys later. Bye.